Today we will look at subtracting algebraic terms. And in the process, we will review subtracting integers, decimals, and fractions. So let's get started. In this first problem, we have 4x minus 1x. So 4x, that can be represented by 4x boxes. We have 1, 2, 3, 4 boxes that represent x. And then we have the minus x, and that can be represented with 1 box for x. Again, when we have this variable x and there's no coefficient in front of it, it means we have 1 times x. The coefficient is 1. So we're starting with 4 boxes of x, and we're going to remove 1. So we're going to take this box right here, and we're going to delete it from this right here. So we're just going to cancel those out. And that leaves us with 3x boxes, or 3x. Now looking at decimals, 0.8y minus 0.5y. The decimal 0.8, that means we have 8 over 10. That is it in fraction form. So if we have a bar representing y, the variable y, and we divide that bar into 10 equal pieces, 8 of those 10 would be shaded. 0.5, well, that's 5 over 10. This is 5/10. This is 8/10. So again, y represented as a bar, and we divide that bar into 10 equal pieces. 5 of them would be shaded for 5/10. So for each blue bar in 0.5, we can cancel out a blue bar from 0.8. So we take 1 and we cross it out. 2, cross it out. 3, cross it out. 4, and 5. And that leaves us with 3 shaded regions remaining within y. And that's 3/10, or 3/10 y. For fractions, again, we're going to take x, we're going to represent it with this bar, and we're going to divide it into however many equal regions that exist in the denominator, the common denominator of these two numbers. So we have this x here. Again, when there is no visible coefficient, we actually have the coefficient of 1. But since we have a denominator of 3 here, we also want our x to have that same denominator. So we can rewrite 1 as 3 over 3, x. So we have this bar representing x. We're going to divide it into 3 equal sections, and all 3 sections will be shaded. And then for 2/3 of those 3 sections, 2 will be shaded. So let's start canceling out these regions. Cancel one region from here, and also from here, and then a second region. And so we've canceled out all the regions that were in 2/3 from the full x. That leaves us with 1 shaded region. Our answer is 1/3 x. Without using the bar models, we can find that common denominator, and we can say 3x over 3 minus 2x over 3. Then 3x minus 2x is x over 3. In this next problem, we have 2/3 y minus 1/2 y. So let's first get a common denominator. In this case, it's 6. An easy way to find a common denominator is multiply the two denominators. So 3 times 2 is 6. This is a common denominator. It also happens to be the least common denominator. So we'll find the equivalent fraction of 2/3 that has a denominator of 6, and that's 4/6. And the equivalent fraction having a denominator of 6 for 1/2 is 3/6. So we're going to take y, represented by this bar, and we're going to partition it, divide it into 6 equal pieces. And so for 2/3, which is now 4/6, we will shade 4 of those 6 regions. And for 1/2, whose equivalent fraction is 3/6, we will shade 3. So now we're going to cancel out 3 of these regions. And that's going to leave us with 1 region. So 1 of these 6 regions in y are still shaded. Our answer is 1/6 y. So now using fraction subtraction, let's go ahead and solve this problem instead of using that bar model. So 2/3 y can be written as 2/3 y over 1 minus, and then we have 1/2 times y over 1. So I'm going to take care of this multiplication first. This is following PEMDAS order of operations. So we can rewrite this as 2y over 3 minus, and then that becomes y over 2. Now we're going to get that common denominator. Again, we found the common denominator of 6. We already found those equivalent fractions over here. So we multiplied top and bottom by 2 and got 4y over 6. And then we multiplied this one by 3 over 3 and ended up with 3y over 6. And now we have a common denominator, so we can subtract our numerator. That leaves us with y over 6, which is the same as 1/6 y. Now let's practice without using those bar models. Again, when we're doing subtraction with algebraic terms, the terms must be like terms. And by like terms, that means we have the same variable. So in both cases, we have an x, and it's raised to the same power. In this case, it's raised to the first power. If you do not see this superscript, this power, it means it's raised to the first power. So we have 11x minus 3x. We can factor out that x. That leaves us with 11 minus 3. 11 minus 3 is 8, so we have x times 8. And then we can rewrite this in the conventional form, putting the coefficient in front of the variable. Now, do we have to go through all these steps? No. So when I'm subtracting algebraic terms, I look at the 2 coefficients, do the math involved, in this case 11 minus 3, bring that value down, and then bring down the variable. So here we have 1.7y minus 1.1y. So I'm going to do that quick math with the coefficients, making sure our decimal points are lined up. We're doing subtraction. 7 minus 1 is 6. 1 minus 1 is 0. Bring down that decimal point. We have 0.6. And then bring down the variable y. Then here we have 1.3z minus z. Again, this is 1z. So we have 1.3 minus 1.0. Do subtraction. That's 3.1 minus 1 is 0. So we have 0.3z. To subtract fractions, we do need that common denominator. Again, we do have a 1 here. So the common denominator will be 4. So that's going to give us 4x all over 4 minus 3x all over 4. 4x minus 3x is 1x all over 4. Or we can write this as 1/4 x. When you do write it in this form, where you have the fraction in front of your variable, do make it clear that the variable is up top, as opposed to writing it something like this, which makes it look like the variable is in the denominator. So this is not good. And probably a better way of writing this is just to get rid of that 1 completely and just say x over 4. So for this middle problem, we have 4y minus 5.7y. So the number, the absolute value of the number that we are subtracting is bigger than the number we're subtracting it from, the absolute value of the number we're subtracting it from. So what we have is 4y plus a negative 5.7y. So when we add numbers that have different signs, we find the difference and then keep the sign of the bigger absolute value. So the first thing I'm going to do is find this difference. So 5.7 minus 4.0. So it's going to give us 7, bring down the decimal point, and then a 1. So we have 1.7. The bigger absolute value was 5.7. So 5.7 is greater than 4. So that means we're going to keep the sign of this bigger absolute value. That sign was negative. And then we bring down that variable. So negative 1.7y. And then finally, returning to fractions. First step is to find the common denominator. In this case, that's going to be 14. It's also the least common denominator. So we'll multiply 37z. We're going to multiply that by 2 over 2. And that'll give us 6 over 14z. And then 1/2 z. We're going to multiply that by 7 over 7. That's going to give us negative or minus 7 over 14z. So we now have 6z all over 14 minus 7z all over 14. So once again with subtraction, we're going to take the difference of the two absolute values and keep the sign of the bigger one. So 7 is bigger than 6. So we'll end up with negative z all over 14. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 3 problems. In the first problem, we will subtract our coefficients. So we have 42 minus 16. We borrow from our tens, leaving us with 12 minus 6. That gives us 6 and 26. So 26x, bring down the variable. In the second problem, we do have 3 terms. So we will follow order operations, and we will add and subtract. In this case, it's just subtract from left to right. So we'll do these 2 terms first. 3.5y minus 1.3y. Leaves us with 2.2y. And then bring down the minus 1y. And then do that subtraction, ending up with 1.2y. So in this third problem, the first step is going to be converting this mixed fraction into an improper fraction. So to do this, we take this whole number part and we multiply it by the denominator. So 2 times 2 is 4. And then we add the numerator. That's 5. So we get 5 in the new numerator. And then we leave 2 in the denominator. So 2 and 1/2 z is now 5/2 z's. And then minus 2/5 z. I'll just bring that straight down. Next step is finding the common denominator. That'll be 10. To convert 5/2 to a denominator of 10, we need to multiply both the top and bottom by 5, giving us 25/10 z. And for 2/5 to become a denominator of 10, that equivalent fraction is 4/10. 25z minus 4z is 21z over 10. Continue practicing subtracting algebraic terms, and I'll see you in the next video.